Hey guys, Mr. Betts here. I'd like to talk about how we're going to take higher order derivatives on parametric equations. So we're going to focus on second derivatives and we won't really do problems with third or fourth derivatives with parametric equations. But the processes that we're going to use here, we could actually use to take higher order derivatives than just second derivatives. So first, a quick refresher. If we want to find first derivative given parametric equations, remember parametric equations, we have x and y independently defined in terms of some third variable, a parameter. In this case, I'm going to use t. It could be a different variable. If we want to find dy dx, which again is the derivative that gives us the slope in the xy coordinate plane, then we can do that by dividing dy dt by dx dt. So this derivative and this derivative are derivatives that we can use, determine using the definitions of y and x in terms of t, and then we divide them. I want to remind you that when we do this, since y and x are defined in terms of t, when we take these derivatives with respect to t, our answer is going to be in terms of t. So when we take this derivative with parametric equations, this is going to be some derivative. I'm going to use m for slope, but the slopes are going to depend on what t is. So it's going to be some function of t. So we need to keep that in mind then if we want to take a second derivative. So again, remember the notation for second derivatives, and I'm gonna rewrite that. The second derivative is given by the derivative with respect to x of dy dx. And the important thing to keep in mind here is that this right here is some function of t. So if we want to take the derivative of that, we have to take the derivative with respect to t. I want to take the derivative with respect to x. So this is going to be something that's not totally intuitive, but we're going to have to account for the fact that we're taking the derivative of this with respect to t instead of with respect to x. And this is starting to sound a little bit like using the chain rule. So that's actually exactly what we're going to do here. To take the derivative of dy dx, we can take the derivative with respect to t. So this is essentially taking the derivative of the outer function, and then we're leaving the t's inside. So those t's are going to be the inner function, and now we have to multiply by the derivative of that inner function with respect to x because we're taking the derivative with respect to x. And we're going to do some algebra here that I've mentioned this before with differentials. We can't really do algebra with differentials the way we can with other things, but we can get away with it in certain cases. So we're going to do a little trick here with this derivative. We don't know what dt dx is, but we do know how to find dx dt. So instead of multiplying by dt dx, we're going to divide by dx dt. So this is essentially just a formula that you need to know. In order to take the second derivative, we can take this out of the formula part of it. So to take the second derivative of a derivative that's in terms of t, we take that derivative with respect to t, but then to account for the fact that we're taking the derivative with respect to a different variable, we have to divide by dx dt. So I did a couple of examples in another video that I would strongly recommend that you watch to kind of see how this is going to work with particular problems.